Chapter 5, Section 6, Graphing Proportional Relationships. So as you can see, our notes are a little different for this chapter, or for this section, and the next section actually. So starting off with identifying proportional relationships. So another way to determine whether two quantities are proportional is to graph the quantities on a coordinate plane. If the graph of the two quantities is a straight line through the origin, then the two quantities are proportional. So in example 1, it says determine whether each relationship is proportional by graphing on the coordinate plane. Explain the reasoning. So the black mamba is the fastest snake in the world. The table shows the distance the snake travels for several different times. Is the distance the snake travels proportional to time? Well, X always comes on top or on the left. Y always comes on the bottom or on the right. So we have our time and our distance. We have our y-axis. We have our x-axis. Since we are in times per second and then we're in meters, and I'm actually going to go by 5s for distance and 1s for time, and so forth. Okay. So at time 0, I'm at distance 0, at the point 0, 0. At 1 second, I'm at 5 meters. At 2 seconds, I'm at 10 meters. At 3 seconds, I'm at 15 meters. And at 4 seconds, I'm at 20 meters. So it is a straight line. It starts at the origin, and since it goes through the origin, we know that it is proportional. So the ratios are, you can also look at it as 0 over 0 equals 0. Actually, I shouldn't. We're not just looking for the rate. Okay. 5 over 1. 5 over 1. So the difference in the y's is 5. The difference in the x's is 1. So we have a constant rate of change. Since we have a constant rate of change, and we have a straight line that goes through the origin, the ratios are constant. So the line passes through the origin and is a straight line. The distance traveled in meters is proportional to the time in seconds. So the relationship is proportional. A candle is 20 centimeters tall. It burns at a rate of 2 centimeters per hour. Is the height of the candle proportional to the number of hours it burns? So again, we have x and then y, and I think 2s would be appropriate on the y and 1s here on the x. Okay, 20 up here. So at 0, we're at 20. At 1 hour, we're at 18 centimeters. At 2 hours, we're at 16 centimeters. At 3 hours, we're at 14 centimeters. At 4 hours, we're at 12 centimeters. So it looks to be a straight line. But what I know just by looking at this, it's not proportional because it does not go through the origin. We can also check our constant rate of change. So 2 over 1, 2 over 1, 2 over 1, 2 over 1. So even though we have a constant rate of change, it's not proportional because it does not go through the origin. Something else that you can look at, for instance, if you don't have a graph and you want to find out if it goes through the origin, okay, you can put your y over your x, 18 over 1. 16 over 2 is 8 over 1, and get everything into a unit rate. 14 over 3 does not reduce well. 12 over 4 reduces to 3 over 1, and you can see that their y over their x is not the same every time. 18 over 1, 8 over 1, 14 thirds, 3 over 1. So that's another reason that it's not proportional. If we go up to this one, so our rate of change told us that we had a straight line. And if we went through and checked each one, so 5 over 1, 10 over 2, which becomes 5 over 1, 15 over 3, which becomes 5 over 1, 20 over 4, which becomes 5 over 1, you can see that their y over x is constant as well as their constant rate of change. So that one was proportional. This one, we can see that our y over x is not constant, even though our rate of change is constant. So it's not proportional, and it's not going through the origin. So it's not proportional. Analyzing proportional relationships. When two quantities are proportional, you can use a graph of the quantities to find the constant of proportionality and to analyze points on the graph. The graph of every proportional relationship passes through the point 0, 0. The point 1r tells you the constant of proportionality for the unit rate r. Okay. So let's look at what we have here. The length of the stretch in millimeters of a spring is proportional to the weight in the grams attached to the end of the spring. So you have this spring going in its circles, and it gets stretched out because it's got this weight down here at the bottom, pulling down on it. So the length of the stretch, so it started this long, we'll say, and now it's stretched out to this long. So the length of the stretch in millimeters of the spring is proportional to the weight in grams attached to the end of the spring as shown in the graph. Find and interpret the constant of proportionality, and then explain what the points 0, 0, 1, 5, and 5.5 represent. So your constant of proportionality should look familiar. K equals y over x. So we just take one point. So we can choose any point here that makes sense and goes through one of the constants here, like 1.5. We don't want 1.5 and 2.5. That wouldn't work out very well. It wouldn't be exact. And here, but here we have exact by having with non-decimal numbers, whole numbers. So let's go with the 0.525. We have our x, we have our y. To find our constant of proportionality, we take the y, put it on top, over the x, and we reduce down 5 over 1. So what does this mean? Well, the 5 is our y, and it's our length, while 1 is the weight in grams. So this is saying it is 5 millimeters of stretch for every gram of weight. So for every gram, you're going to get 5 millimeters of stretch. Explain what the point 0, 0, 1, 5, and 5.25 represent. So that just means these points right here. So the point 0, 0 is when there is 0 weight and 0 stretch. It is 0 millimeters of stretch or no grams of weight. The 0.15 is when there is, that's 5 millimeters, because that's in the Y, 5 millimeters of stretch or 1 gram of weight. And the 0.525 is when there is 25 millimeters of stretch or 5 grams of weight.